All right, let's jump in. So looking, this is week 3, day 1, and at this point, other than WebSockets and maybe some stuff about authentication, I have gone through the majority of what I have to share as far as content goes. A lot of it now is going to be taking those same parts, rebuilding them, and making them work together, leaning on the React side. So if you feel a little behind on React still, there is no shame at reaching back to assignments, even all the way back to the to-do list. I've seen it happen. I've seen people get through the server and feel comfortable, and when they're ready to tie it back together, they need to brush up on a little bit of React. No shame in that. Um, all of that said, I want to build a new project and add some features to it over the next couple of days, and stress what this build process is going to look like for just about every Mern application that you can build. A lot of this stuff are things that can and should be done before you attempt the black belt on Friday. So these are basically things that apply to any project, and you should already have up and running. There's no reason to do something like npx create React app under exam time. You should already have that up and running. You shouldn't have to do things like import Axios, or even even have a lot of your backend code up and ready. So this is what I start off with. I created a new project folder, and the name of my project is week 3, day 1, whatever. I went inside of it and I created a Git repo with Git init. This is pretty important, but I'll get on to why in a second. I worked on my server, so I said npm init-y, which gave me this beautiful package JSON. I grabbed a server.js, which is currently empty. I installed Mongoose Express and cores. So if we look at package.json, I have Mongoose Express and cores. We no longer need Faker API or anything like that. And then I created a server folder, which for now is going to need config controllers and models. I think that's as complicated as I'm going to get. I think the platform shows it slightly differently, but I want to stress that this server organization is up to us. We can make it as complicated or as simple as we want. I've accepted people who've turned in their black belt test where technically the entire server is still on just server.js. You do not need to modularize for the test. But in full stack Mern, we show you and give you code that's already modularized and expect it, and I'm going to do it for this demo. So I just want to, I'll point out the things that need to be different, but I recommend it personally for large projects, but it is not necessarily a requirement as far as passing or failing. The other thing I did is I ran create React app, which created this React app for me already. Cool. This is important. The reason why this file is so important, and the reason why I did it after I ran git init, is because if I do not run git init on an outer repo and build it, npx create React app client will create a repo itself. And you don't want a git repo of just the client and a git repo of just the server. You want it all wrapped together. And I get this question a lot, especially when it gets to deployment. People get all the way to deployment, and then they get all the way to that final step, and they look on their Git repo, and the entire client folder is invisible. It's empty. There's nothing there. And they're like, why? And the reason why is they created React app, and then they created the outer repo. The outer repo looked at client, which was now its own Git repo, and ignored its files because it said another repo is already tracking this. 2 repos cannot track the same file. That's against the rules. It should be the same repository, and if you really want to do something, you can set it up with the Git remote. So I made sure that this was built after, and this is all part of the same Git repo. The only other things we need to do within this client now is you'll notice that we're missing a couple dependencies. So let me just add those dependencies in right now. I need to cd into my client, and what I'm going to say is npm install. I want to install I want to install Axios, which I think is just Axios. And then I want to npm install this. I think is at reach router. I think it's at reach router. Let's see if it works. Beautiful. Okay, cool. So we installed the reach router, we installed Axios. Those were like really the last two parts that we needed to get up and running on our app, all right? So let's kind of add that to our setup. Navigate into the React client, npm install reach router Axios. Okay, cool. So this is our main setup, and we're gonna have to do this just about any projects that we make. In fact, we're actually still missing one thing that I wanna go back to. So let's back up one level. Let's cd into the server folder. Let's create config. Let's create controllers. Let's create models. All right, cool. So cd back. All right, cool. So let's start by building out the server, because I think the server is kind of like our main entry point to the application. So I'm going to create some constant variables. So express is going to require express. And then we'll say the app variable is express but invoked. We'll create a port, and we'll say, let's say 9001. And I'm just going to hard code the port, and I'll show you why in a second. Let's go ahead and say we need cores, require cores. And we'll say app.use for cores. All right, this is letting us send cross-origin requests from React's port of 3000 to our server's port of 9001. Cross-origin request. It's a security thing. It's good that our server doesn't default accept these kind of requests. And then what we're going to say is app.use express.json. This is a small thing. We just want to make sure that our app can send and receive JSON requests, especially in our post data. All right. And then at the very bottom, we're going to say app.listen on port. We're going to console log. Oops. I'm going to console.log app running on $port. All right. Beautiful. So that's our server so far, and we're going to open up a new terminal down here. And we're just going to run it. I'm going to shrink my text just a little bit. So we want to run the server. So what I'm going to say is node mod server.js, and that will be running my app on 9001. All right, beautiful. And we got some more config to do on the back end, and I usually start with the back end config. So going back to this terminal, this is going to be our open terminal for creating new files. So I'm going to go into server. I'm going to cd into config. I'm going to touch a routes.js. I'm going to touch a database.js. Sometimes we call this database file mongoose or mongoose connect. We'll back out. I'm going to cd into controllers. Oops. I'm going to touch, well, actually, wait.
You put routes in the config rather than giving it its own folder generally?
I take it the platform puts routes in its own folder.
Yeah.
I think that's what I was trying to remember. I usually put it in config because to me, routes is kind of like configuration.
Okay.
But it's up to you. We can put it in its own folder, but I'm going to mash them together.
Cool. That was just curiosity.
So here we are, and we need to create a model for the first time. And I believe the platform has us building, what is it, like a products dashboard? And I want to do something a little bit different. Let's do a database of colors. So what I'm going to say is I'm going to touch a file called color.js, cd back, let's cd into controllers. I'm going to touch a colors.js. Controllers should be lowercase and pluralized. All right, cool. So now I have some new files in the server: database, routes, controllers, and models. So what I'm going to first do is I'm going to go in and I'm going to configure the database file. So let's say const, we got to bring in Mongoose. We're going to say mongoose.connect, and we're going to connect to mongodb at localhost / colors database. I want to make sure it's unique. And we're going to need this big ugly object. And the reason why we need this big ugly object is because otherwise it'll complain at me. So we say use new URL parser. It's true. Used unified topology. That's also true. And use find and modify. That is false. All right, cool. And then eventually we can modify this file a little bit more and do some other stuff in it. But for now, what we should do is we should import it into server.js. So what we're going to do is down here, we're going to say require ./ that's where we are. We want to go into server. We want to go into config. We want to go into database and require that file. Cool, the app is running, the database is connecting. Let's go into routes. Routes needs to be a module.export. Export of a function that takes app. Inside this function, we'll have our routes, and we should import something called, let's say, let colors equal require / controllers / colors. So we're bringing in a controller over here. And then our controller can be a module.exports. And this module.exports is going to have, say, index, which takes a request and response. That's going to get some kind of response to it. And let's say get one, it's a request and response. And then let's say create, gets a request and response. All right, we'll start with that for now. So that's our controller. And what we could do is we could take our controller and bring it into our routes and start defining some of things. So app.get for /API / colors is going to get us colors.index. All right, let's make a few more of those. Let's say app.get for /colors. Passing the ID is going to get us to colors get1. And app.post for /API / colors is going to get us to colors create. All right, so we have a couple routes. Let's go back to our server. Let's import that routing file. Routes is a function, so let's go ahead and call that function immediately and pass it app. And now we have app available on our routes. We have these routes. All right, so let's create our model. All right, because we actually need something to kind of send back and forth into the database. So we're going to kick this off with const mongoose require mongoose const color schema equals a new mongoose.schema. And for our colors, I think what we need is a name, which for now is just going to be a string. And then we need a hex which is going to be a string. And I mean, is that really all a color has? It'll have a name and a hex. We'll keep it simple. Yeah, let's start off with that. You name the color and you give it a hex selector. Even though a lot of those probably already have names, let's not worry about it too much. And then the other thing I want to attach onto this is timestamps. So let's have timestamps true. All right, cool. What is a hex? So let's just look at something really, really quickly. Not to get too far on tangent, but this is relevant. Let's say we want HTML colors. When we think of a color, there are three ways to think about it. There is the hex key, there is RGB, and there's this thing called hue. I forget what SNL stand for, but that's just another way to kind of modify the color. Most of the time, we care about the hex value because that's what I can feed directly into CSS. RGB is another way to kind of express different colors, but it's just a fancy way to express a color. If you take literally any color on a color picker, no matter how advanced, saturation and luminance, thank you, James. If you take any one of these colors, no matter how advanced, it's going to give us a hex number. So what I want to do for this app is I basically want to give people a color picker. There should be an HTML color picker. There should be like a default one, just in an input type color. Yeah, see this? No. HTML5 has an input type color, and it gets you this, which is pretty cool because it gets you a cool color input, and this is just built into HTML5. So you can let a user drop this in, and I'm pretty sure the output for this comes out as hex. So when we're on React's side and we actually output these colors, we're probably going to get a hex number, and that's what I'm going to save. So I'll save the name of the color, I'll save the hex of the color, and then heck, I'll even say the RGB as a string, I guess. I'll just have these for now for the colors that I'm trying to save, all right? So that's my color schema, and I have timestamps to it. And we can go a little bit more advanced with this. So like, let's say instead of a name, we can say it still has a type of string. We can set it to be required true, so they can't leave it blank. And we can give it maybe a min length of 2. Color name must be 2 or more characters. Right? And then for our hex, we can just say, hey, you know what? The type is going to be string, and we're going to say required true. Now, if I were going really hardcore about this, if you guys remember way back in Python, we had these things called regular expressions to find out whether an email address is an email address. I'd probably use a regular expression to require the hex to be a valid hex, like start with hash, be base 16 numbers, A through F or whatever. Anyway, this will also be a type string, required true. All right, cool. This is our color schema. And in order to make this proper color, we're going to say mongoose.model color the color schema. Beautiful. All right, we're going to require this in our database file. So require, where are we? We want to back up one level. We want to go into require, back up one level, go into models, go into color. Now, how the platform shows this, again, is it exports the model at the bottom. But if you create this mongoose model first, we can call it with mongoose model again. So we're creating it here, we're requiring it in the database connector, The database connector is running here on line 11. So inside of my controller, there's nothing stopping me from saying const mongoose require mongoose const color equals mongoose.model for the color we defined and passed to schema. So if I could do this, I can go into this controller and actually fill it out with data. So all of these generally look the same. It's color dot something, right? And that dot something has a dot then. That dot then has a result, which we output as res.json result. And it has a dot catch with an error that we res.status and make sure it's a 400 code. And then we say .json and we spit that error. Right, they all look like this. So because they all look like this, I'm going to take this code and drop it into everyone. All right, let's start with index. This is just going to be find, and we're going to find all. And I'm going to be a little bit more specific, and I'm going to say, hey, you know what? I'm getting all of the colors. And I'm going to be yet even more specific, and I'm going to break this up into a multi-line statement with curly braces. And on my server, I'm going to say console log, we are in colors.find. And then we're going to console.log colors. Then we return with the response, right? Why does it matter? Maybe we want to wrap this in params first. Where is it now? Where is it? Schema hasn't been registered for model color in the controller. Why would that be? Because autosave isn't on. Now it's fixed. All right, cool. Autosave was not on, so it was getting mad at me. Cool, let's go back to our routes. Let's go back to colors. The same thing counts if we're trying to see one of these error messages. If you're having trouble seeing what the response is, there's nothing stopping you from just writing on the server console log error. It helps to leave yourself a little notification of where it happens. You could use breakpoints if you really want to stop the application at this point, but you care about this error. It's important to you. And sometimes you care about this error to read it on the server before we send it out to the client side for the client to see it, all right? So let's do get one. So this is gonna be find one. And there is a bunch, there are a lot, let me stress. If we go into color dot, there are delete many, delete one, find by ID and delete, find by ID and remove, find one and delete, insert many. Like there are a lot of things that kind of seem like they do the same thing. Update many, find one by ID and update one. What's the difference? I recommend using the simplest and most general one in all purposes. So for us, instead of find one by ID, we're gonna just say find one, right? And then inside this find one, we're gonna say, I'm looking for the underscore ID and I want it to be the rec.params.id, right? Where did we get this ID variable from? I defined it right here. If you want, you can put an underscore here and make sure that it's always underscore when you're talking about Mongo IDs, but I personally don't do that. But you do have to remember that when you're searching for your database, you're searching by the underscore ID, right? So we're gonna say color.find1 by the underscore ID. If we get a result, this result is technically just a color, not colors. Or if we can't find anything, we throw an error. Beautiful. All right, let's get to create. Create is very simple. We just pass in the rec.body, no matter what it is. All right, it's the model's job, it's Mongoose's job to validate whether this thing is correct. If it's correct, we should be getting back our new color that we created. Otherwise, we get creation errors, all right? These creation errors are important to us because it means that we failed, basically. And eventually we want to present these to the user and let the user see them. All right, so we have a lot going on. Let's ping my server real quick. Does anybody remember the command I used for that? I'm going to say curl local host at 9001/API/colors. We are in colors.find, spit out an empty object, spin out an empty object. All right, this is looking pretty good. So why don't we bring in Postman? And using Postman, we're going to interact with this thing a little bit. And in addition to Postman, I think I'm going to use this color picker just so we can bring in proper hex codes. All right, so here's Postman. I don't want any of this on. Just shrink it. That's fine. All right, so start off, clear off everything. If you use Postman for the first time, again, you see this screen. I just click in the grayed out area, or I click the X because I don't care about it, and I just create my new things, all right? So I'm going to create a local host 9001/API/colors. See that I get my response. See that the server is still serving the way we want. Cool, we're happy with all of this. So why don't we do a post? So we want to post to local host 9001/API/colors. We want to do body data. We want to do raw. We want to do JSON. We're sending over a JSON object. That JSON object has a name. Let's say default blue. Default blue has a hex. That hex is going to be this color right here. We'll go back to Postman. And then it also wanted an RGB. I'm honestly not sure how this is going to look when we pull it out of our form. So I'm just going to take these numbers and pass them in as a string. It'd be fairly easy to grab these three numbers and split them apart if we really, really had to. So I'm going to send.
Generally, it should be presented with parentheses around it for RGB as well. Just that's normally how it's shown. So in the same way that there's always the hashtag in front of a hex, RGB is always in parens.
I had a half a mind to save it like this too. So maybe I'll save it actually like this, RGB parens 51102.
Yeah.
Anyway, let's send this in. Hey, it created my new color. All right, let's see what happens if we mess it up. I'm going to send it nothing at all. And it gets mad at us. It sends us an object with the keys of errors, message, and message. Okay, message is kind of useful because it shows us some information, but this is really not a user-facing error message. Color validation failed, RBG, path RBG is required. This isn't something that you show to the user. You show them a dressed up error message, right? And we have dressed up error messages, at least for some of these. So like, here's a more dressed up error message. If we go back in here and I make the default name X and I send that in, all right? This is the error message I want, the error message that I wrote, all right? This custom error message, it's friendly, it's user facing. But something you'll notice is whether I have one error message or many error message, it goes into a key called errors, and every key in errors is a field that threw an error, right? So right now it's just name. If I get rid of all of these, it's going to be name, hex, and RGB. So errors contains these three keys, all right? Kind of a pain. It really should be an array, right? We should be using an array for this because the keys are predictable and we don't know how large it's going to be, right? So converting these errors into an array will make your life so much easier. And where you should do that conversion should be on React. So we can't really deal with that right now, but when we get onto React side and we want to show these errors easily, it will benefit us a lot to make it into an array of error messages rather than this big nested object, right? Working with nested objects in React, for the lack of a better term, sucks. It's not very good. It's kind of hard to do. There are some kind of like gotchas you can do. Like you can say key and next key, and you can basically use these things called optionals. So ending every one of them with a question mark, but I'm pretty sure we need to import something to use this. I could be wrong. It might be default and built in, but I'm pretty sure we need to import something. And it just kind of looks ugly. There are better ways to deal with this situation. There are functional ways to deal with this situation that we will get to. All right, so let's do a couple more tests, and one of them should be getting back all of our colors. Beautiful, we're getting back all of our colors. Let's see if our search by ID works. So let's say localhost 809001/API/colors/this ID, and we get back my color parameter. Beautiful, all right? So this is about as far as we can get from server-side code, all right? Our server looks about this complicated. We have a main server file that holds the port and imports some basic stuff and requires database and routes. Database, I almost never need to look at. Mostly the only thing here is the name of the database, right? Routes I'm interested in because this shows all of our entry points, all right? This server cannot handle any route other than these. If you make a typo, if you say API/color, it happens all the time. I mean, I do it to myself. I'm surprised we haven't done it in a demo yet, but you just name the route and then you think about it again and it's different, right? So going back to this routing file, you should always see the routes that are available for this application. In this case, it's only these three, all right? A controller is basically just method names and then a database call. Anytime we have this capital color, this model that we're talking to, and it calls something like find, save, anything like that, it's a trip between Node and Mongo. And because it's a trip between Node and Mongo, we send a promise, all right? That promise says, when you are successful, I want you to run this. If you fail for whatever reason, I want you to run this, right? Promises are useful in this JavaScript environment because it lets us predetermine what the outcome of a particular action is going to be. We can say, hey, I want you to take a trip to the database, and when you are done, on success, do this, on failure, do this. It fits into how JavaScript behaves because remember I mentioned before a while ago that JavaScript is non-blocking, which means that if you write something like color.find, you'll notice that we're never doing something like, just as an example, let's say, we never say let colors equal color.find, and then on the next line, we say return, or say res.json colors, right? We never write code that looks like this, even though in Python, in C#, in Java, we write code that looks like this all the time. Problem is, in JavaScript, JavaScript is non-blocking. If this takes a trip to a database, this is going to run before this function can finish thinking and responding and putting data into it, all right? And because of that behavior, we can't write code that looks like this without jumping through some hoops, all right? What we do instead is we write a function call, and then we pass more functions into it as the results. Okay, so we've done a lot. Well, we did quite a bit on the server. Final thing I'll mention is the model as well. The model is really the structure of what we build. In a lot of the projects that we work on in the next couple of days, and even the belt test itself, the model should be really the first thing you think about and you build, and with feeling comfortable that you might need to revise your model at some point, right? The model is what drives the application because it's what dictates the behavior of the controller, right? The model dictates how create works, right? What are the rules of create? What are the fields necessary for creating? And because of that, it dictates how the entire React application works. My form needs to look like this, all right? My display page needs to look like this. If I have dummy data in the application for when the application first loads, it needs to look like this, all right? This kind of like runs pretty much everything. It's the masthead of the behavior of the application. All right, so looking into our client now, I think one of the big things that we did is, I'm just gonna put an H1 that says hello world. And inside this React app, we're gonna bring in use effect, right? And I think we remember what use effect does. I'm also gonna bring in Axios, so import Axios from Axios. And then we're gonna say use effect takes a function to run and an empty array. Oops, get out of there. And this function is going to say axios.get for localhost 9001 /API /colors. All right. We're going to have a .then where the response is going to be console.log to us. Right? And then if we have a .then, we have to have a .catch. Ooh, wait, what did I do? All right, cool. If we have a .then, we have a .catch, which takes an error. All right, and inside that, we'll just console log the error. Right. We've used useEffect to talk to other APIs, but now that our API has cores installed, we should be able to call it as well. So now we cd into the client, we say npm start, which is going to start our React app. Me personally, I like to have my server and my React server running kind of side by side in my editor, because they kind of are the drivers of everything that's going on. And then I have an extra terminal window, and this terminal window is for creating files, for navigating through things, and if I ever need to talk directly to the database, so I can say sudo mongo I can show DBs, and I can find that one, what was it, colors database right over here, right? Cool. So we started it, it's starting. I guess we could just go back to our browser. It says hello world. If we inspect it, we should be seeing some kind of message, but we're getting a cores blocked policy from localhost 3000. All right, so how can we fix that? If we're getting that, we can do is I just need to include HTTP. So we're saying HTTP localhost 9001, which is here. Refresh the page. Still doesn't like it. Cores policy. What we can do . Can read it here. So maybe I just did something wrong with my course setup. Use cores. This looks right. Is it app.use or app.set? Let me check my notes. This could just be a very small difference. Const cores requires cores. App.use cores. It's coming in before everything else. It's not a problem. We're importing cores. That's not a problem. Let's go back to our client. Why is this behavior happening? Oh, did I forget to save it? Yeah, I'm funny. One of the things I turned off this morning for morning algos is I turned off autosave, and we're going to run into that in my demos for the rest of the week because I'm very used to it. I just need to save the files. Anyway, we have the data coming in. Hey, this data is coming in. It's the data that I want. It's the hex data that I want. So really the next step is to send this data out and be able to create new colors to add. So if we had to do that extremely quickly, I would say that we need a form. So we're just going to do it here. So let's create a div. Let's create a form. Form is going to have a on submit, which will need to be equal to something eventually. Inside of it, we'll have inputs. This will be an input type text for the value of name. Change, we will say E, and then we'll say set name. Oops, whoa, calm down. Set name, I realize I don't have it yet, but I don't want that. E dot target dot value, I believe, is what we want. Okay, cool. So if we have all of that stuff, we need use state real quick. We're going to say const name, set name, use state. Let's do a couple more of these for hex and RGB. All right, let's go in here and do one for type color. Color. I guess I'm just going to leave this as type text. I'll put something weird in here, but that's fine. And then we say set RGB. All right, cool. So we have 3 state variables that handle okay, cool. We have 3 we have 3 state variables, 3 form inputs, 2 text, 1 color. We have an on submit. All right. So this on submit, we're going to have a form handler of some kind. So let's create a const form handler takes an event, and we're going to go into that event, and we're going to say e.prevent default to prevent the page from refreshing, and then we're going to say axios.post to http//localhost 9001/API/colors, and we need to post an object, all right? That object that we're gonna post, I might as well just create it. So we can say const or let new color equal this object. And this object is gonna have a name, which is gonna be our name. And it's going to have a hex, which is going to be our hex, and it's going to have an RGB, which is going to be our RGB. And right before it goes out, I actually just want to console log this new color. We'll get to this Axios post in just 1 second. Oh, on submit, we're going to run form handler. All right, cool. So go to our browser. We have a form. That's really lame. Oh, I have no submit button. Let's fix that. Input, type, submit, the value of 8. Oh my God, I'm making so many mistakes. Okay, cool. Refresh it again. All right, we can put a name in here, super gray, and we can choose a color, and that color has a very specific RGB. So 94, 90, 90. All right, and we can create a color. And when we do that, cool, we get the hex, we get the name, we get the RGB. All right, beautiful, that's a good start. And I don't think it matters if we change this thing at all. We'll still always get just the hex value coming out. Okay, cool. So that's a good start. And if we can get all of that data in a serialized object, we can post it. So Axios post takes 2 things. It takes the URL, and it takes the new object that I'm trying to create, the new color. This is my form data that I'm passing in, all right? Now in response, I have a then with the response that I should be getting. We'll just kind of console log the response. All right, but I also have a catch for any errors that come out. And if those errors come out, we will console log the errors. And yeah, let's do that. And it's this error. Yeah, okay, so I'm gonna show some things. All right, cool. So this is where we're landing. I can create a new color allegedly. Let's say it's really red, and the RGB is like, what was it, 113, 13, 13, something like that. Okay, we can create a new color. All right, that's my new color. I send a request, I get back, hey look, it's making it, it's having no problem creating this file. So if I get rid of these things and maybe submit this instead, my response is I get this bad request. This is good. I want to see this error. I want to see a 400. This was a bad request. But I also get this thing that just says error. This is at app.js line 37. So if we look closely, that's the error that I'm getting. So that's not really useful to me. I can't console log this. This isn't even a string. So I need to go into error.response, right? The error object has a response. So let's try and create something. If I go into the error object response, now I'm getting usable data. Inside of there, there's data as well. So I can say error response.data.errors. Seems like we're really digging at this point, but now when I try and create something faulty, I'm actually getting an object back with every key that's wrong and a properties that shows every message of why it's wrong. X is required, Color must be at least 2 characters.